Good afternoon, students. Welcome to Analytics Powered Interactive Virtual Classrooms. Okay, so how are you all, students? Are all of you all right? Having fun? So, very good, students. So, I hope all of you are doing well and study properly. Okay, so, students, in our previous lectures, in our previous 2 or 3 lectures, we have completed the chapter which one is a story of numbers. Remember, a story of numbers. Fine. So today we are going to start a new chapter from your textbooks, which one is called Quadrilaterals. Okay, so Quadrilaterals is your chapter number 4. So we are going to start the introductory portion of Quadrilaterals today. Okay, so there will be some several parts of quadrilaterals will be there. Okay, which will be followed after suppose 2 or 3 days prior. Okay, so without any delay, I am starting today's session. Fine. So look. So in your screen, so you have seen there are some certain solar panels are there. Okay, these are some solar panels are there. Okay, solar panels. Fine. So now my question is that what's the shape of that kind of solar panel, sir? What's the shape? Okay, what's the basic name of that shape? Okay, that the solar panels have. So what will be it? So look, so in the solar panel, so it's look like, so there are total 4 sides are there, correct? So look at the screen. So there are total, that's the solar panel. So we have seen that the first side, the second side, the third side and the fourth sides are there. Total number of sides is equals to 4, correct? Right. Then what is it? It's the game of chess. Okay, all of you know. So fine. So it's the game of chess. So in each of the portion, so you have seen that, so it's a shape of quadrilateral. It's a quadrilateral. Quadrilateral means 4 sides, correct? So the shape of the chessboard is also a quadrilateral. Okay, it's a quadrilateral having the 4 sides basically, right? Then so look at the table here. So now look at the table. So the table looks like what's the shape actually? So we will learn in our upcoming classes, but up to today's class, so it's a quadrilateral. Fine. I'm changing my pen. So it's named as quadrilaterals. It's the shape of a quadrilateral. Correct? Right. Then what is it? Yes, all of you know it's a kite. Okay, we have seen that. So there are some certain boys and girls are playing out there in the at the ground, and they are flying the kite. Okay, nice. So the shape of the kite is another quadrilateral. Okay, it has 4 sides. Look. So look at the screen. So you have the shaded part or the highlighted part that shows that. So this kind of kite or this kind of figure has 4 sides. Okay, nice. Then what is it? So when we see from the front side, so it's again shows us it's a quadrilateral. It has 4 sides, correct? So students, the ultimate what's the ultimate thing? So ultimate thing is that in the first screen we have seen some solar panels are there. So I am taking that one, the solar panels. Second one is our chessboard. Okay, we have the chessboard. In the third one we have seen such kind of table is there. Such kind of table is there. Okay, then we have seen the kite. Okay, so it's a shape, basically geometric shape. Then we have find this one. So all of these shapes are called as quadrilaterals. Remember, all of these kind of shapes are called as quadrilaterals. Similarly, so quadrilaterals consist of 2 words. Quadrilaterals consist of 2 words. The first one is quadri and the second one is laterals, or it can be called as latus. Okay, like this. So where quadri means 4, quadri consists of 2 words. Okay, we are dividing the word. Okay, so quadrilaterals. So quadri means 4. So quadri simply just means 4, and the next part is laterals, or you can say normally it's a latus. Okay, so latus means is sides. Latus means sides. So ultimately, what's that mean? So it means that so it has exactly 4 sides, correct? So if I ask you a question that what kind of shapes will be called as quadrilaterals, so what will be your answer, students? Nice. So you will say that sir, those shapes which have exactly 4 sides are there, so those kind of shapes are called as quadrilaterals. Simple. Okay, fine. Then quadrilaterals. Okay, so look, so these kind of shapes are all are called as quadrilaterals. 1, 2, 3, 4, 5, 6, 7. So these of all kinds of shapes are called as quadrilaterals. Because why? Because we have seen that in all the four total 7 figures are there. So in all the 7 figures we have seen that there are exactly 4 sides are there. Okay, right. So now look, so there are some certain shapes are there: A, B, C, D and E. Okay, so now look, so which of the following figures is not a quadrilateral and why? Which of the following figures is not a quadrilateral and why? Quadrilateral mean what? 4 sides. Now what is called by side, or what does it mean by side? What does it mean by side? That we know that in our practical geometry we have learned that a side is a part of a side is a part, okay, a part of a line. A side is a part of a straight line. Straight lines is represented by this one. Remember, straight line is represented in this way, that both the ends are not fixed. Both the ends are not fixed. So this kind of line is called as straight line, and we are taking the part of a straight line, right? We are taking a part of a straight line which is called side, or similarly you can say that the line segment is there. Okay, similarly you can say that a side is simply just a line segment. We are taking that part only. We are taking that part only. We are taking that part only. Okay, so that's a side. Okay, that means we have to take the line segments. The line segments. Okay, it will be linear. It will be a linear line. Okay, just normal, a simple one line. Okay, no curved line will be there. It's simply a part of a line, a part of a straight line. So straight line is means straight. Straight line means in the word straight line means what? Straight, full straight. Okay, no curved lines will be there. So the line segment just simply means the side. Okay, so now look at the screen. In the figure A, so it's a straight line, correct? It's another straight line. Yes, it's correct. Okay, it is another straight line, correct? It is another straight line, correct? So A will be a quadrilateral or not? So whether our figure number A will be a quadrilateral or not? So what will be the answer? Yes. So option number A will be a quadrilateral. Means figure number 1 should be a quadrilateral, because all of them are sides or line segments are there. Okay, the figure A consists of 4 lines, 4 line segments. Okay, so that's why we are saying that the figure number A is a quadrilateral, correct? Now look at the figure number B. Now look at the figure number B. So here similarly we have seen that, so it's a straight line. Very good, it's a straight line. It's another straight line, correct? It is another straight line, and similarly it is another straight line. So for that case we can also say that the figure number B is also a quadrilateral, right? So figure number B is also a quadrilateral. Very good. Option number C, look at the option number C. So it's a straight line, or it's a line segment, right? It's also a line segment, right? It's also a line segment, as well as it's also a line segment. So it will be another straight line. Okay, sorry. It will be another a quadrilateral. So figure number C will be a quadrilateral also, right? Now look at the option number D and option number E. Now look at option number D and option number E. Okay, so that is a straight line, fine. That is another straight line, fine. That is another straight line, fine. Now the next one, now look at the next one. This one is like this. This one is like this. The next side is looking like this. So now you tell me, students, is it a quadrilateral or not? Now you will tell me that is it a quadrilateral or not? What will be the answer? So my basic question is it a line segment, students? Is it a line segment? Is it a line segment that is a straight line? No, it's a curved line. We have seen from our naked eyes. Okay, with the help of our naked eyes, we can see that it's a curved line. So it will not a line segment. It will not a line segment. So you can say that figure number D is not a quadrilateral. Figure number D is not a quadrilateral. Okay, understand? Nice. Similarly, for the figure number E, we have seen that it's a straight line, correct? It's another straight line, it's also correct. But the next two, is like this. So with the help of our naked eyes, we can see that definitely it's a curved line. It's definitely a curved line. Okay, and similarly this one is also. So it's another a curved line. So similarly you can also say that our figure number E is not a quadrilateral because they do not have all the sides like they are not all sides. Okay, so there are some curved lines are there. So for that reason, so these two, the remaining two, that is figure number D and figure number E, are not called as quadrilaterals. Fine? Correct. Very good. So figure number A, B and C, and it's a figure number of D and E. So you can say that they formed by the, okay, so you can say that they are formed by the four straight line segments. They have made with four straight line segments. Okay, while our figure D and E, they are not formed by four line segments. Okay, as I have mentioned earlier. So our figure number A, B and C, they are made with the line segments, straight line segments, while our figure number D and E, they are not made with our straight line segments. Correct? So that's why these three are called as quadrilaterals and these two are not mentioned as quadrilaterals. Okay, or they are not quadrilaterals. Okay, yes. Fine. So now there are some properties of some quadrilaterals. So we will study that one. So properties of a quadrilaterals. Fine. So the first property is they have exactly four vertices and four straight sides. Vertices mean that one. Okay, so these intersecting points of two sides are called as vertices. Intersecting point of two sides are called as vertices, and four straight sides. So this one is, that one is another, that one is another straight side, and that one is another straight side. So four vertices and four straight sides will be there in a quadrilateral, in every quadrilateral. So it's a first and the basic property. You see that. So this one is okay. So now one second. Okay. So now look. So from the now what have I done? What have I done? So I have done that I am attaching. Okay, I am attaching the opposite vertices using a straight line. I am taking a line which joins the opposite vertices. I am taking some lines, okay, some straight lines, okay, which joins the opposite vertices. So that one and that one, that one and that one, that one and that one. Similarly for that one and that one, and similarly for that one and that one. Now, what are they called? Okay, so what are they called? So these straight lines. So the answer will be what? These lines are called as diagonals. Remember? So these lines are called as diagonals. So there are some diagonals of every quadrilateral. Okay, there are some diagonals. Fine. So diagonals is nothing but a straight line, okay, or a line segment which joins the opposite vertices. Which joins the opposite vertices is simply called as diagonals. Correct? Fine. Now, so look. So now, okay. So we have seen that they have exactly four angles will be there. So the first angle is there, the second angle is there, the third angle is there, and the fourth angle is there. So similarly for the other ones, okay. So there are exactly four angles in a quadrilateral. So these are some basic properties. Okay, there will be some four angles will be there. Now my question is that what should be the sum of the interior angles of a quadrilateral? What will be the sum of the interior angles? Now what is interior angles, sir? So interior angles are those angles which lies inside, okay, which lies inside the figure, okay, inside the figure. So there will be some angles will be there. So that kind of angles are called as interior angles, and there is another angle which is called as exterior angle. So exterior angle we are not learned today, okay, we will not learn today. So up to this, so we have learned that. So what should be the sum of the interior angles of a quadrilateral? We have to find out what is the value, okay. Right. So now look at the screen. So there I am taking, so it's a quadrilateral A, B, C, and D, and it's the same quadrilateral I am taking here. Okay, I am taking here the same quadrilateral A, B, C, and D. Okay, nice. So now look at the screen. So now, so yes, so using the compass, I am creating some, or I have drawn some angles. Okay, I am named the angles is angle 1, angle 2, angle 3, and angle 4. So these are the names of the angles: angle 1, 2, 3, and 4. So total 4 angles are there, and these angles are also particularly called as interior angles, right? Fine. So now look at the screen. So now I am cut out all the angles. So after cut out by the scissor, so what I get? So 1, 2, 3, and 4. So you have seen that. So after attaching all of the cutout portion of the angles, so we will get a complete circle. We will get a complete circle. Okay. Okay. Using the angle 1, angle 2, angle 3, and angle 4. So it's a complete angle. It's a complete angle, right? So it's a complete angle. Now my question will be that what's the angle formed at the center of a circle? Okay, so what's the value of the angle, okay, make at the center, which is made at the center of a circle? So what will be the value? So very good. So those who know, so they will say that the total angle or a complete angle measures 360 degree. That's called the complete angle, right? Nice. So look, so now the boys think that the sum of the interior angles of the quadrilateral is equals to what? Very good. So the sum of the interior angles of a quadrilateral or any kind of quadrilateral is 360 degree. Is 360 degree will be the total interior angle, the total sum of the interior angles. Okay, fine. So now there is a question time for you students. So using your raft system, you have to answer correctly of this question. So the today's first question is, what is the maximum number of diagonals of a quadrilateral can have? What is the maximum number of diagonals a quadrilateral can have? Option number A, 1, 2, 3, and 0. What's the diagonal? Diagonal is a straight line. Okay, diagonal is a straight line or a line segment which joins the opposite vertices, okay. So I'm giving you 30 seconds of time, so answer it properly, students, that what's the maximum number of diagonals of a quadrilateral can have. Okay, okay students, 10 seconds more. I can see that all of the students are giving the correct answers. Okay, okay students, and the time's up. So our answer will be option number B, 2. How? I am taking any quadrilateral. So we are taking like this. So this quadrilateral we are taking. Okay. So its vertices is the first vertex. And now tell me, so according to that vertex, which of the four, which vertex that this one, and this one, which will be the opposite one? Nice, very good. So it will be the opposite one, okay, against that vertex. So just join it with a line, okay. So that is the first diagonal, and similarly, so it's another vertex, okay. So for that vertex, we are taking this vertex, okay. So that's the opposite one. So we are taking this one. So that's our diagonal number 2. So the total 2 diagonals will be there in every quadrilateral, okay. It should be it's true for a rectangle, a square, rhombus, trapezium, parallelogram, whatever you have, okay. It's true for all the cases, okay, fine. Then rectangle. So our first quadrilateral is rectangle, okay. So that's the basic shape of a rectangle, you know, okay. So A, B, C and D. So A, B, C, D is a rectangle, correct? So in a rectangle ABCD, so all the angles are 90 degree. So that's the basic property. All the angles are 90 degrees, sir. So that one is 90 degree. So that measures 90 degree. That measures 90 degree, and that angle also measures 90 degree. Okay, using the protractor, you will check. Okay. So the opposite sides are of equal length. That's also true, that AB is equals to DC, AB is equals to DC, and similarly AD is equals to BC, AD is equals to BC. So the opposite sides should be equal. The opposite sides should be equal in measure. Okay, like this. And now let us learn some few more properties of a rectangle. Okay, we will learn some few more properties of a rectangle. Okay, now what properties are? So if you see in your textbook, so there is a problem. So that's problem calls a carpenter's problem. Okay, there is a carpenter. So we will see some more properties of a rectangle by using a carpenter's problem. Okay, what a carpenter needs to put together two thin strips of wood. Okay, thin strips. Thin means no thickness will be there. Okay, so two thin strips of wood as shown in the figure like this. So that's a strip of wood and that is another strip of wood, okay, in the figure, so that when a thread is passed through their endpoints, whenever a thread means what? Thread, you all of you know, um, is passed through their endpoints. Endpoints means their vertices or vertices. So if we pass the thread using or through their endpoint, so it will forms a rectangle. It will form a rectangle like this. So look, so he already has one 8 centimeter long strip. Okay, so the measure of one strip he has taken, so that one measures 8 centimeter, correct. Then what should be the length of the other strip? What should be the length of the other strip is our first question. And the second question is, where should they both be joined? Okay, where should they both be joined? Okay, now look, so let us first model the structure that the carpenter has to make. The strips can be modeled as the line segments. Okay, line segment means our straight line segments. Then they are the diagonals of the quadrilateral formed by their endpoints. Okay, they are the diagonals of the quadrilaterals formed by their endpoints. We have seen in the last figure that this one is that kind of strips are there. He is taking that kind of shape. Okay, one is intersecting the other one. Okay, so now this kind of shapes is called what? So that is our first diagonal. If we think properly, so that's our second diagonal. So that's why we are writing that they are the diagonals of the quadrilateral formed by their endpoints. Understand? Very good. Then look, so like this. So that's our 8 centimeter wooden strip, and that is another centimeter wooden strip. Okay, so Look what. So for the quadrilateral to be a rectangle, so it's a quadrilateral, fine. So for the quadrilateral to be a rectangle, we need to answer the following. We need to answer the following question. So there will be some certain questions. Okay. So the first question will be, what's the length of the other diagonal? Okay. We have seen that. Suppose he is taking two wooden stripes. The first one is of 8 centimeter. So what will be the measure or the length of the second one? We have asked that what is the length of the other diagonal. So what will be it? And the second one is, what is the point of intersection of the two diagonals? What is the point of intersection? Like this. So this one. So what is the point of intersection of the two diagonals? Okay, fine. So we are going for the first question. So diagonals of a rectangle seems to be equal. Seems to be equal means until this we are not able to prove. Okay, so to prove that the diagonals of a rectangle, whether they are same or they are not same. Okay, so for a instance, I am taking that the diagonals of a rectangle seems to be equal. Means it may be equal, may not be equal. Two possibilities are there. So it may be equal, may not be equal. So there are some certain differences. Okay. So up to this, we are taking that the diagonals of a rectangle seems to be equal. Okay, it may be equal. It may be equal. Okay, so these two. Okay, so the length of these two may be equal or may not be equal. We will prove that. Okay, like this. So by applying a logic, we can confirm this fact. So it's a fact. Okay, it's a fact, or you can say it's an axiom. Okay, it's an axiom. So by applying a logic, we need a logic in every mathematical field. Okay, so now in this way we are applying a logic. So by applying a logic, we can confirm this fact that whether the diagonals are same or not in length. Okay, so whether the diagonals are same in length or not. Okay, so look, so we are taking this rectangle. Okay, ABCD rectangle is there, fine. So now we are taking the first diagonal, that is AC, and it's our second diagonal, that is BD. Okay, now consider, we have to consider or put that triangle, it's a sign of triangle. Okay, it's a sign of triangle, remember. So triangle ADC. So what is this triangle ADC? That's our angle, this one, and using the diagonal this one. So it is, if you observe carefully, you can see that angle ADC represents this one, this portion. So this portion is represented by angle A, D and C. Angle A, D and C. Okay, and angle BCD. So now what is BCD, sir? So B from C to D, and now you have to add this one. So this is another one. So that part is another one, angle B, C and D. Triangle B, C and D. Triangle B, C and D. So we are considering these two triangles. The first one is angle ADC and the second one is this one. We are comparing these two triangles. Okay. So now for first consider these two triangles. So look at the screen. So that is the highlighted area of the triangle ADC, and that's the highlighted area for the triangle BC and D. Okay, fine. So for an instance, we are taking, look, AD and BC. AD and BC, so they are the opposite sides of a rectangle. So they should be same. Okay, it's a basic property of a rectangle. Okay, all of you remember, it's a basic property of the rectangle, means opposite sides of a rectangle should be similar or should be same in length. Okay, so AD and BC is equals to, AD is equals to BC. So both of them should be same. Okay, so they have the same length. So AD is equals to BC. Why? So the reason is the opposite sides of a rectangle ABCD. Okay, so every fact we are writing, so we have to find the reason behind it. Okay, we have to write the reason behind it, why we are taking like this. So AD is equals to BC. Why we are taking like that? We are taking that the opposite sides of a rectangle ABCD should be same. So that's why AD is equals to BC. Okay. The second one is, look, A, B and C. So and B, C and D. So now what? So angle ADC is equals to angle BCD. Why, sir? That's our second formula. Oh, sorry, our second property. So the second property says that the interior angles of all the interior angles of a rectangle measures 90 degree. All of the angles, okay, or each of the angles, interior angle of a rectangle measures 90 degree. Remember? So that's why I am taking that each angle of a rectangle is equal to 90 degree. So that's our basic reason, okay, or valid reason we are taking, okay, angle ADC. So that's why we are taking angle ADC is equals to angle BCD. So ADC, that angle is equals to BC and D, that one, BC and D. So that one. So for that reason, the each angle of a rectangle is equal to 90 degrees. So for that reason, we are taking both the angles are similar or same in measure. Okay. And the third one is, look what. So DC, we are highlighting the DC. Okay. So DC is equals to what? So DC is equals to DC. It's a valid reason. So the what is the reason? So reason is the common side of both the triangles. So for angle ADC, okay, I'm taking for the angle triangle ADC. So DC is there, okay, and similarly for the triangle BC and D, the similar side will be BC, DC. So DC is equals to DC. So that one is for angle ADC, for triangle ADC, and that one is for triangle BC and D. So for both the case, we have the common side, that is DC, of the both the triangles. Okay. So after that, we are taking that, look. So we are taking this one as per the side, because ADBC, their sides. That one is we are taking in the case of angles. In the case of angle, so that is an angle, and that denotes another side. Okay, that is another side. So now in the sequence, we are taking what? Side, angle, side. We are taking side. Okay, as per the side basis, we are taking AD is equals to BC. As per the concept of angle, we are taking angle ADC is equals to angle BCD, and for the next one, for the basis of side, we are taking DC is a common side of both the triangles. So side, angle and side. So in this sequence, side, angle, side. So it will be our what? It will be what? The congruence. So congruent triangle. So we are taking by SAS congruence condition. S means side, A means angle, S means side. So side, angle, side. So using that sequence, we are taking by SAS congruence condition. Now what? SAS congruence condition, angle triangle ADC and triangle BCD will be congruent triangles. Okay, will be congruent triangles. Congruent triangles means, so there are some certain similarities will be there in both the triangles, like that, in the basic sense. Okay, so there are some certain similarities will be there in both the triangles, angle ADC and angle BCD. Okay, so that's why by CPCT, that is congruent portions of the common triangles. Okay, so congruent parts of the common triangle, so we are taking what? AC is equals to BD. So we are taking AC is equals to BD. AC is equals to BD. So AC is equals to BC is equals to what? In the basic sense, these are the diagonals of a rectangle. So these are the diagonals of a rectangle, correct? So that's why we are taking AC is equals to BD. So we have proved that one using the SS congruency rule, okay, or by the congruent mode of the both the triangles, that is angle ADC and angle BCD. Okay, nice. So the diagonals of the rectangle have the same length. So in the first question, we are measuring that both the diagonals may be equal, may not be equal. Okay, we have some possibilities are there, 50% yes, 50% no. That is, both the diagonals of a rectangle should be same or shouldn't be same. So ultimately, after the congruency of a triangle, so we are taking some basic rules, okay, and after we have proven that one, that is AC is equals to BD. So now we are able to say that the diagonals of both the diagonals of a rectangle should be same in length. Okay, so I hope all of you will understand. Okay, so the next assignment we will learn to in the tomorrow's class. Okay, so up to this, any doubt, students? We are going to learn the introductory portions of the quadrilaterals. Okay, so quadrilateral is what? Quadri means four, and laterals or laterals means sides. So basically it means four sides. Whichever shape you are taken, those shapes have the four sides, so that shapes will be a quadrilateral. Okay, so in the quadrilateral we have seen some properties of the quadrilateral, and after that we are taking an example, that is the first quadrilateral, which is rectangle. So we have seen some basic properties of a rectangle, and then we are going to move a carpenter's problem. Okay, so that's our actual topic, so we will learn in our next class. Okay, so in today's class we will just find out the first question. Okay, so whether the diagonals of a rectangle maybe shouldn't be same or should be same. Okay, so there are a possibilities arise. Okay, a possibility is arise. Okay, so after the using of the congruency of a triangle, that is the using some basic formulas, so we have proved that the diagonals of a rectangle are same in length. Okay, so up to this I am going to end today's session. I hope all of you enjoyed today's class, so we will meet you in the next class. Okay, so thank you students, bye bye, and take care students, enjoy your time, see you in the next class.